So my name is Juan Yu. I'm Impala field engineer, work at Cloudera. So I work on Impala project for 3.5 years. And I'm also an Impala committer. Most of the time, I help customer to tuning Impala, fix performance issue, fix scalability issue, help them stabilize their cluster, optimize their workload to achieve the SLA. So before we start, since this at Strata, we encourage everyone to networking with each other. So I'd like to ask everyone probably just to spend 2 to 3 minutes, talk to the person next to you, front of you, behind you, just like, yeah, where you see what company, organization you're from, and what you're looking to learn from this tutorial. Okay, that was great. That hopefully now everyone already know the people around you, and then you can help each other during the exercise. Okay. So everyone here have anyone never used the Impala before? Okay. Okay, that's not bad. So most of the people that ever used the Impala before. So how many people ever look at Impala query plan or profile at least once? Okay, cool, pretty good. So what do you feel? Do you like look at it or? Yeah, so at the very beginning when I just started working on Impala, I have the similar feeling as you guys that the Impala's plan profile seems so complex. It's very difficult to reason about where the problem is, how to interpret those metrics, and why that some run is slow, some run is fast, and where the bottleneck is. Don't worry. So after this tutorial, I'm sure that you will have like the general idea. You can probably solve a lot of query performance issue. So just to give you a quick idea about. Oh shit! I can't know. Okay. Quick idea about query plan. How does it look like? The profile. You don't need to read the text here. Just have a rough idea to see how long it is and kind of how gigantic the text is. So this is the profile part. And you can see there's tons of metrics. And for this one, it only runs on, I remember, 8 nodes cluster, but the profile itself is almost like 10,000 lines. And if you ever like brave enough to look at the thrift one, it's completely like a puzzle. Okay. So today, the whole tutorial, I'm gonna split it to 2 parts. The first part, we'll talk about all the basic stuff, what's the query plan profile, why we why we need them, and what's the goal of them, and what kind of issue they can help you solve, and what's the basic structure of them, some basic troubleshooting. And the second part, I'm going to focus more on the performance tuning, how to identify bottleneck, more advanced query tuning, and how to use the Impala optimization. So I assume that most people familiar with the database term, like what means scan, join, predicate. But if you if at any time you have any questions, feel free to ask, or any term that you don't understand, you want some explanation, just let me know. Let's start with a simple example. So here's 2 queries. You can see that here the first query takes like 3.6 seconds. The second one take only less than 300 milliseconds. So can anyone tell me like why the 2 query take different time? Like if you are familiar with database. Okay. Sorry, could you? Yes. Yes, exactly. That's how the partition planning make the difference. Partition planning make. So if you look at the execution summary about the both query, and even though they're both similar structure, like just a scan aggregation to get the final result, but at the you can see the scanning part, the left one kind of have to scan 800 million rows, but the right one is less than 8 million. So there's like 100 times difference. So that make a big difference. That's how the Impala, when you run the query, it will be smart enough to know that you filter the query by a partition key. And then since it's a partition, the file data is organized per partition. Like usually each file, for each partition, you put the file in a separate directory so that the query engine knows that it doesn't need to scan all the directory, all the partition. So the right side, you can see only scan 30 partitions, and there are only 30 files. So when you execute query, if you can take advantage of partition planning, it can reduce the work significantly. Not only since the execution model is more like a volcano model, so the smaller the base is, and then the less intermediate result, less intermediate work it needs, and the query will run much faster. Does everyone knows where to get the query plan profile? Okay. So there are at least 3 main ways you can get query plan profile, and each one has its advantage. So I'll just quickly demo each of them so you can understand what's the difference between them, and when you need, if you have permission to access all of them, and at least you have a choice. You know that which one is the most suitable for you. By the way, all the profile example I'm gonna use for exercise today can be downloaded from the GitHub here. And if you haven't downloaded it, you can just go to there, and they're not big, so it should be fine. Just access it through your browser. So let's start with the Impala Shell first. So the Impala Shell is just a command line tool, and from here you can run any regular SQL command. SQL command. For example, you can just show tables here. You can execute a query here, and you can also get the query summary and profile here. So if I run this query, after I finish it, I can just run summary. I will be able to see the summary here. And if I just tap profile, I can get the whole profile here. The advantage of the Impala Shell is you can set different explain level to examine the plan first. For example, the left side and the right side, they're the same query. I'm running explain for the same query. And the left one, let me change this to be a little bit bigger. Okay. So the left one is explain plan is the normal detail level. So you will only see the operators here and the tree structure. If I change that to be a single node plan, you can see the plan is now more simpler because it removed the exchange part. This is what we call the single nodes plan. That's what when the Impala's planner trying to compile the query, the first plan it generated. So this one helps you to examine if the drawing order is correct. Because it's simpler, it doesn't have the exchange in the middle that kind of confusing, so it's easier to read. But when you really want to know how the query being executed, you want to see the full plan, the distributed plan. So this plan, besides the basic thing on the basic operator part, there's exchange added in the middle. So that tells Impala like which part they can run in parallel and at which point they have to exchange data to be able to continue the next step of work. And it also has all the information like the fragment, how they organize it together. Yeah. This one is the same as just put the explain. Just do the explain, but you need to set the explain level. So you see the bottom part. So you just need to set the explain level. Yeah, so there's 3 levels, 1, 2, 3. By default, the level is 1. So that's what the left side, what you see. That's just a basic. And with the explain level to 3, you can see a lot of details here. You can see that the memory estimation, you can see their the tuple size, cardinality, all the statistic will be showing here. So this helps you to examine that if this plan is reasonable or not, if it's a good plan or not. So this is Impala Shell. And the second one, probably most common used one, is from Cloudera Manager. In Cloudera Manager, there's from the cluster menu, you can go to the Impala queries. And this will give you the query histories, all the query histories here. Usually, Cloudera Manager can default keep like 1 month's query history. So from here, you can see a lot of history query. The next thing here is there's also some aggregated statistic, query execution statistic on the left side. For example, it calculates the query based on its peak memory usage. So you know that which query is your most expensive query. Same thing for how long, which one is the longest one. And there's also heuristic show you that how much percent of your query, for example, are I/O heavy and how much are not. So this will help you, can give you the basic information like what's the query pattern of your workload and also resource usage pattern. So you can use that to plan how you can design the dynamic resource pool, how to do the resource allocation. So besides the aggregated information, you can also examine individual query from here. So if you just select one of the query, go to the drop-down menu here, there's query details. So this will list left side, that's the query plan. And that's also at the level 3, the most detailed one, similar as you see in the shell. And on the right side, that's the basic query information, all the summarized information. Similar as the aggregated part, a lot of metrics here are aggregated by CM. So you probably won't be able to find them from the query, the pure query profile text format. But CM does those for you to kind of highlight, for example, the client fetch waiting time is small percent or big percent. and what's the percentage of your remote read, and the CPU time here. And at the bottom part, it breaks down the profile by query fragment and fragment instance. So all the fragments will be listed here. We will talk more detail about what the fragment instance means. So the nice thing here is for each fragment, it will list which Impala daemon is involved in this fragment execution. You can quickly jump to a specific instance. And also, by default, for most of the query, the list here is ordered by the execution time. So the one at the bottom usually is the one execute fastest. The one at the top is the one that executed the slowest one. So you can quickly to see that, oh, which one is slow, and if it's if there's any common patterns, why this one is slow. So from CM history page here, you can download the text format or Swift format, the one that I just showed at the beginning, so that you can use other tool or check for other information. The third one is Impala Web UI. So Impala provide a debug Web UI. In the Web UI, there's a query history page. So this one will be only available if this Impala D is used as coordinator. In the Web UI, Impala Web UI part, by default, it only lists the recent 25 queries. So it doesn't keep all the histories because those profiles, Impala keep it in memory. So you don't want to keep a large query history in the memory. That will reduce the memory you can use to execute query. So the nice thing about this UI is if you go to the detail page, so it will show you a graphic plan. So the plan tree, so by default, whatever the plan you see in CM on the Impala Shell, the one you see is like a text format. It has a lot of information, but it's a little bit hard to see the relationship between the operator, between the fragments. But with the plan, with the graphic plan, you can easily see how it looks like. And the two nice feature here is you can choose different visual effect. You can choose either just show the fragment by the execution time. The warmer the color is means the slower this operator is. So from here, you can quickly identify which operator takes the longest time. And if you want to understand how the query is being break down to fragment and executed, you can uncheck this box. Then Impala will mark the operators based on the fragment, how they organize combine to the fragment. Here also it shows the nice table of the execution summary, and the profile part is similar as the text one. So it's a long kind of JSON format with all the metrics. This web UI is updated like in live. So by default, it's every 5 seconds you will get a new status update. So if you check the plan here, you will see that the number actually keep updating while your query is running. So this also can help you understand if my query is hanging or if my query is still running, it's just a slow or whatever. This is intermediate result size. So those number will keep updating. Like for this one, since the query is already completed, the number won't change. But if my query is still running, you can see that the number will keep changing. Yeah. So that can give you idea, like if your query is stuck there or if it's actually moving, it's just slower. Yeah. And if it's during running, you can also see at real time the memory usage for the different fragment and operator, and how many backends involved here. So this is when you trying to identify for individual query, like what's going on. I think this is the best. This is the best to help you to get that. The backend here actually mapped to every Impala daemon. So I think at the next slides, I'm gonna briefly talk about the Impala architecture. So there I'll explain what's backend, what's front end. Yes. Yeah. Yeah. Only coordinator has this query page, has valid query showing there. Yeah. If it's not coordinator, the query page will be empty. Yes. Okay. So why do we need the query plan? So when you want to run the query, there's basically two things we want to achieve. First is we want to have the query executed as fast as possible. Second is we want the query used as less resource as possible. So if we don't have a query plan to compare what's the best way to execute the query, you might end up with a very slow query or using too much resource. That's why, like on the Impala query engine, we were trying to find the cheapest and fastest plan. Its main focus is to get lower cost of the query. So this is done by reducing the unnecessary work as much as possible. For example, through partition pruning, through predicates push down, runtime filter. All those helps reduce the I/O, reduce the scan. And by reduce the scan, the I/O, your intermediate result will be smaller. And you will need less memory, less CPU to process it, and less network bandwidth to send it. And the second goal is by to achieve better performance, we want to maximize the scan locality. Means that we want to use the Impala D that has data as locally as possible. So this way, you don't need to read the data through network. You can just read the data from the local disk. So we utilize the data nodes block metadata and to find where the data is and then schedule the work on that node. And after the scan part, and we also trying to minimize the intermediate result transfer. So think about if you want to join the two table, usually you will build hash table for one side and then do the probe. So if you have usually you want to have the small table into the memory and then do the probe on the for the left table. So this way you use less memory and you don't need to hold the large table in memory, and you can do that in kind of pipeline streaming model. So that helps you save resource, run faster. So that's why we spend a lot of effort to optimize the join order, and also the choose a better join strategy. Since the data is distributed on all the hosts, when you need to build a hash table, you have to make a decision. Do I want to like broadcast data to all the nodes so each one hold the hash table, or do I want to partition data and put just a small percentage of data in each node and doing the join? So that's what the planners work to find what's the best join order, what's a better join strategy. So last but not least, you want parallel. This is a distributed system. It's you want to utilize as many nodes as possible, so you can reduce the execution time for each task and achieve a better query performance. Query profile is a runtime and the final execution result. So it provides a lot of metrics counters to help you to know that how the execution is ongoing and how much resource is used, like network, memory, and how much I/O rate, and how long each piece take, so that you know that if the whole time is, if every time spent there is reasonable or not, if there's any bottleneck, abnormal behavior. So we're going to see a lot of examples about how to identify the bottlenecks. So just a quick summary about what type of issues query plan and profile can help you solve. From the plan side, you can identify if there's missing stats, if the partition pruning is effective, if the partition, if the predicates is pushed down to the scan level, if the join order is the optimal one, how about the join strategy, and how many hosts are involved in executing this query. So all those information, actually, you can find it in the plan. We'll go through a plan example for each of them in details. On the profile side, you can identify bottleneck and see that if runtime filter is effective or not, and knowing how much resource your query use, and if there's any problem with, for example, your network, or if there's any data skew, execution skew there. On another side, the problem slowness could coming from client side or could come from depending service, underlying service, like for example, name node. And from the profile, there's also some metrics to help you to kind of isolate where the problem is. Query plan profile is very good for analyze individual query issues performance. So sometimes it can also help you to identify if the system or the, for example, on the data level, if there are any problems. So that can help you solve lots of issues. So the normal flow of a SQL query is the client sending the request to Impala daemon. The Impala daemon, it has two parts, the front end and back end. The front end is written in Java, and the job of it is mainly compile the query, generate the plan, like to perform all the work we just discussed earlier, to find the proper join order, to do the partition pruning, predicates push down, to do all those. Once it's find out the optimal plan, it will distribute it to all Impala backend. The backend means each Impala executor. So in the process level, the backend and the front end and backend actually in the same process. It's the same binary. It's just that it has two different responsibility, depends on what kind of request they get. If it gets the already compiled the query plan, it's just doing the execution part. And during the execution, we collect a lot of metrics, generate the query profiles, each backend sending those status report to coordinator in an interval. So the coordinator side can combine all the status report, show you the profile and what's progress of the query. At the end, once it's finished, we send the results to client. Yeah. There's no cache for the query plan, so each request is treated as a new one. Yeah. Every Impala D can act as either coordinator or executor. The front end is just this for the same process. It has different functionality. So the part of front end code written in Java that is all in the same process. Yeah. So let's quickly review the Impala's architecture. That probably can help you understand a lot of like this architecture side. So Impala service has 3 roles here. It has catalog, state store, and the Impala D. Catalog is the one that doing the metadata cache. So the metadata cache here, including the one we mentioned, the data locality metadata, and the schema metadata, and also the security-related information, authorization information. So those, once the catalog load those information, it cache it, and then send it to state store, then distribute it to all the Impala D. So each Impala D itself is both, like has 2 parts, has both the front end, has the back end in the same process. So just depend on what request it receives. Then the Impala daemon will talk to the storage layer to execute the query. So for a real query request, the client send request to one of the Impala daemon. Whoever you send the request to, that one behave as a coordinator, so that it will start the front end part work, doing the query compiling and generate the plan. Then the coordinator will distribute the plan to all other Impala daemon, including itself, if it's also an executor. Then its executor will communicate with the storage layer, doing the scan and doing the exchange intermediate processing. Once everything's done, the data will be sent back to the client side. So that's the basic structure. So now let's talk about the each part in detail, from the planning to execution. When I demo the Impala Shell, I quickly show that you can have a single nodes plan, you can have a distributed plan. So the reason here is we want to start simple. We want to start with a single nodes plan to see how I can break down a query to execution plan to run it. So at this time, single nodes plan layer, we trying to assign the predicates, push down to the lowest level, lowest operator, and see that if any columns are not needed, if you need either not filtered by it, not projected it, or not joined by it, then we don't need to read it at all. Especially if you use Parquet, we can just scheme the whole column. Same thing for partition. After analyze the query, if this partition is not needed at the execution, we can just prune it. And at the single nodes layer, we calculate each join level to see the cardinality, decide the join order. And also we determine like which runtime filter can help reduce the resource usage, speed up the query. So this is all done at the single nodes plan level. So once we finish all the single nodes plan, the next step is we will see how we can execute it. This is the distributed plan. As a distributed plan part, we find out what's the best Impala D to execute the work, to run the work. So you find the one that has the data locally. And we pick execution strategy for join to find which way is the cheapest one. Should I broadcast the table, or should I do the partition join? Last thing is we will insert exchange operator at each fragment level, so that after you finish all the work you can done at the single nodes, Now you can shuffle the data around, and all the nodes can work together to do the next step. So here's a query example. The operator here is the one like I just mentioned, that is how query engine execute each task. Like some operator probably just scan the columns, the rows for a table. It's called scan nodes. And you can see from this select query, we have a 3 table we need to scan. So they're mapping to the 3 scan nodes. Then there's also other operators, the join here, they're mapped to the join node. There's after we finish join, there will be grouped by having this map to the aggregation part. The last one is this order by that map to the top end. That's how we compile the query to execution to a query plan, so that it can be executed later. Each operator has some cost associated with it. So at the join part, we will base on the cost of the 2 scan sites to see how we should adjust the join order. So at this step, this is you do the compile the query, generate a single node plan. The next step, as mentioned, that we translate the single nodes plan to the distributed plan. So you can see the main difference here is we insert some exchange here. We insert some exchange here at each level. Because after you scan this one, and you have to put everything, build the hash table. If your data exists on multiple nodes, then now you have to like combine them together and to build the hash table. And to reduce the network traffic as much as possible, we will try to do some pre-aggregation, merge aggregation before we continue, so that the network we need to use here can be reduced. The exchange kind of just connect between the nodes, because if you are doing the scan here, the data can be distributed to 5 nodes, right? Each one just have 20% of data. But when you need to do some aggregation, to do some join here, you need to build the full hash table. The hash table have to contain the whole data, not just 20%. So at this time, like each node, after they scan the data, they need to send the data to every node so that you can build a full hash table. That's just one example. Similar here, after you... sorry, this one, okay. So similar after the hash join, before you do the aggregation, you can do the pre-aggregation on each node. So just aggregate whatever data they have on this node. At the end, you need to send all the pre-aggregated results, for example, to coordinator to do the final aggregation. It's just a network transfer kind of operator. Okay. So the fragment usually break down at the exchange level. You can see that whenever you have exchange, that means that you need a new it's a separate fragment, because you don't have the full picture of the data. You need to rely on the exchange, send the shuffle data around to continue the next step. So at the plan level, we call each group of work fragment. And those fragments are when you do the execution, those fragments can be executed on multiple nodes. On each node, that where you really execute a fragment, we call it fragment instance. So we will see those in the query profile. Because each node you can have different data, um, different data, different resource usage, so that they will have different metrics. So the fragment instance is reflect what's the resource usage on this particular host. This is just the visualization tree. We already saw it one at the demo. This is, you can get it from the Impala web UI. So let's talk more about the query execution. This is a simple two-table drawing query, and we added a hint to indicate that we want to use a shuffle drawing. You can see that there's the basic two-table scan part, two-table scan, and then there's this hash drawing part that mapping to the tree set. The data will flow from bottom to the top, to the root, until it reach the coordinator, have the final merge result, then send back to the client. The plan structure, if you're using the experience level 3, you will see that we actually mark each part of the fragment. If you're not using the fragment 3, you will only see the tree. You won't be able to see the detail of each fragment. And at the fragment level, we will indicate like how many hosts involved here, and also the resource usage, average resource usage for each host. Finalize means that at the final step, you probably need to do some final aggregation. That's just the last step, the last work. Finalize. It will, but in the profile, not in the plan. In the plan is more just an estimation. So if you want to know accurate resource usage at coordinate level, you have to look at the profile. Yeah, when we work through the profile, I'll point that out. Yeah. What? The random? Oh, this is just to indicate like at the exchange part how they're gonna send in the data. So you're talking about the one here, right? Yeah. So it's more just when we exchange the data, actually there's a different way to exchange data. It can also broadcast or just randomly send to another host. There's like, depends on your query. So, yeah. Right now, you can only specify if that's a single node or using whatever best for it. We have a Jira to track that. So depends on the request, how many customer people request that feature, we'll consider like adding it. Yeah. It won't work. The num nodes is only 1 or 0. So 1 means single nodes plan, 0 means that distributed. Whenever it's distributed plan, it will try to use all the best nodes. It doesn't pick randomly just a subset of nodes. It doesn't do that. 0 means distributed plan. Yeah. Oh, this one just for example. This doesn't based on any, I just want to have the shuffle there to show you the plan, how the query being executed. Yeah. Yeah, then if you add the hint usually has priority. So as long as you put the hint there, Impala will try to follow the hint. But if you don't have the hint, Impala will base on the statistic and all the calculation. So we will see how to calculate that later. Yeah. Impala doesn't support index right now. No, it doesn't. But it does have a parquet min-max filter that can kind of like can mimic some of the index feature. I'll quickly talk about those later. Yeah. For the distributed system, usually it's a good thing because you have a lot of data and you distributed the execution to many nodes so that they can read the data locally and being executed faster. Otherwise, if you read the data all through the network, the performance will be slow. But the skill and the performance sometimes kind of conflict to each other. When you at certain large scale, the distributed cost might be too high. So at that time, you might want to shrink the computing side, not using all the nodes. Okay. Any more questions? Yeah. The data distribution is not the query engine's job. It depends on your underlying system, storage system. If you use HDFS, and by default, it will goes to the current nodes, whoever you're writing the data, the client is, and then randomly picking two other nodes to put the data. And if you run the HDFS load balancer, the data can be moved around. But those are not query engine's job. Well, whatever query engine does is based on where your data currently already is. And then I'm finding out the optimal plan to execute. Yeah. Okay. So the query, okay, I think we already finished the plan part. The profile side, the basic structure is kind of like also a tree structure mapping to the query plan, but it has some summary information at the top. So it has all the basic query information. For example, which user is executing the query, which node is used as coordinator, what's the type, and what's the query status. Then it will also embed the full plans in the query profile. After that, it will show you the execution summary. That's if you don't remember how to read any of the metrics, but just remember how to interpret the execution summary. That probably can already help you solve half of the problem. There's also a detailed timeline about at the query compiling time, each step, how long they take, and the query execution part, what's the major part each part take. After all those summary information, it will be the per fragment information. So we will break down for each fragment instance, and show that how long each one takes on different hosts.